here's 3.5. It's all about transformations. This is where we're going to take the knowledge of our basic curves from 3.4 and understand how we can move them around in the XY coordinate plane. We can stretch them, shrink them, flip them, rotate them, everything. We're going to talk about how we can recognize this by looking at the equation. So here, we're going to look at vertical shifts up or down. When you see something being added or subtracted to the outside of your function, that is going to change your y coordinates. Anything outside of the function changes the y. When we go to the inside of the parentheses where the x is, that's going to change the x coordinates. So if my graph is f of x is x squared, there's my basic parabola right there. And I add 2 to the outside, so f of x plus 2, or in this case, x squared plus 2. That means every point on this curve has to shift up 2 squares because we're adding 2 to all the y coordinates. So I'm going to find the 5 points of my graph. Right there at the origin, 1, 1, negative 1, 1, negative 2, 4, 2, 4. And this graph, like I said, every one of those points are going to go up 2 squares, and there's your new parabola. And if we subtract 4, then those 5 points that we have right there, they all shift down 4 squares. There's our new parabola. All right, outside function changes the y's. Inside changes. This is going to shift things left and right like the x-axis is going. However, it's technically going to have an opposite effect. So again, looking at my x squared function, if I have f of x plus 2, that means x plus 2 is inside the parentheses before I square it. Okay, this is not what you think. It's not going to go to the right. It's actually going to take that to the left. It's opposite of what you see. And one rule that I like to do is just simply do this. Take what's ever inside your parentheses, set it equal to 0, and solve for x, and that's going to tell you exactly what's happening. So x plus 2 equals 0, x equals negative 2, everything's going to the left 2. Now, another explanation of that is think of this point at the origin. This is the point 0, 0. Okay, I need to square a number to get to 0. Well, if I look at the inside here, I don't want to move 2 to the right and be at 2, because then for my x, 2 plus 2 is 4. 4 squared is 16. I need the whole thing to be a 0. So negative 2 plus 2 is 0. 0 squared is 0. Let's take a look at this point here at 2, 4. Okay, at 2, 4, I need everything inside of this parentheses to be equal to a 2, so when I square it, it's 4. So the only value I can put in here would be a 0 for my x. Notice where's that point at that we moved to the left 2? It's at 0, 4. 0 for the x, okay, 0 plus 2, 2 squared is 4. There we go. Now, if we're subtracting on the inside, again, opposite effect of what you think is going to happen, this is going to be moved to the right 4 squares. So those 5 points right there are all going to go to the right 4 squares, and there's my new parabola. So that's our shifting left and right and our up and down. All being added or subtracted. Now remember, outside adding and subtracting affects the y coordinates. Inside the function affects the x coordinates, but in an opposite manner. All right? Now, vertical stretching and shrinking. This is done by multiplying. So here we're going to multiply something to the outside of our function. So remember, outside function changes your y-coordinates. So now if this says 2 times f of x, and our f of x is x squared, or 2 times x squared, that means every y-coordinate of your points have to be multiplied by 2. So here's my 5 points. Think about if we label them. Here's 0, 0. You take that y-coordinate of 0 and multiply it by 2. Whoops, it's still a 0. But then these 2 points here have y-coordinates of 1. Okay, 2 times those 1's for the y-coordinate become 2. So that's now negative 1 comma 2, 1 comma 2. And for these 2 points, I'm at 2, 4, and negative 2, 4. We're going to take those y-coordinates of 4 and multiply them by 2. They become 8. So I'm now at negative 2, 8, and positive 2, 8. And so there is my parabola. I'm multiplying 2 to my y-coordinates. I am physically taking all those points, or think about grabbing each side of the parabola and stretching it upward. All right? Okay. What if we multiply by a fraction, which is like saying we're dividing by 2, f of x divided by 2, or 1/2 times x squared? I like to think of multiplication here. So again, we're going to go back and we're going to take every y-coordinate again and multiply it by a half. Well, half times 0 is still a 0, excuse me. So we're still at the origin. At those 1's, well, 1 times a half is a half. So now we're going to shrink. We're heading towards the x-axis. We're shrinking downward. And these points over here that were at 2, 4 and negative 2, 4, half of 4, or 1/2 times 4 is 2, move down to here at negative 2, 2, and 2, 2. And well, that kind of sounded weird, 2, 2. So here is my parabola. I am shrinking it down to the x-axis. Now, the next type of shrinking and stretching we can do is horizontally. That's where something is being multiplied to the inside of my function. But remember, if it's on the inside, it has an opposite effect. So here we're going to look at the absolute value graph because it's easier to change these numbers because they're basically on straight lines. But the absolute value graph, there's my V-shaped curve. Now, if I multiply by 2 on the inside, let's say 2 times x inside my absolute value bars, this is really going to have an opposite of effect. When we were doing vertical, this is really going to say, hey, take all your x coordinates, don't multiply by 2, but divide by 2. So that's why I chose the x's that at 2 and 4 here. So 0 divided by 2, still 0. But here at negative 2, 2, and 2, comma 2, divide the x's by a 2. That's going to make this negative 1, comma 2, and 1, comma 2. So you can see now we're starting to horizontally approach the y-axis. We're shrinking it towards the y-axis. These points at negative 4, 4, and 4, comma 4. Again, take the x coordinates, divide them by 2. That puts me at negative 2, 4, and 2, comma 4. Again, these points are shrinking horizontally towards the y-axis. And there's my graph. If we had the multiplication of 1/2, okay, so now I'm going to kind of change this because otherwise I'd fall off my graph. Multiplying by 1/2, well, that's like dividing by 2. Well, we're going to do the opposite of dividing by 2. We multiply by 2. Or the opposite of multiplying by 1/2 is dividing by 1/2. Well, you don't divide by fractions. You really multiply by the reciprocal. So we're again multiplying by 2. So 0 times 2, opposite of effect, is still 0. But negative 2 times 2 And 2 times 2 is going to make those x coordinates a 4. My y coordinates didn't change. Now you can see my blue points, now they're being horizontally stretched away from the y-axis, or away from the original curve. When this x is negative 3, multiplying that by 2, that's going to take me out here to negative 6, comma 2. And this 3 being multiplied by 2 for the x changes it to a positive 6. So now you can see my blue graph here has been horizontally stretched away from the y-axis, or away from, if you will, the basic absolute value v-shaped curve. So that's your horizontal stretching and shrinking. Now, let's talk about reflections or flips. This happens when you multiply by negatives. So here, if we have the square root of x as our function graph, we saw this one earlier, 0, 0, 1, 1, 2, 4. If we multiply a negative to the outside of my function, that's going to change your y coordinates because it's outside. So that means this point has to flip over the x-axis. Well, wait a minute. It didn't change. 0 times a negative for that y-coordinate is still 0. This y-coordinate is a 1, and if I multiply it by a negative 1, that's going to flip it over to 1 comma negative 1. It just flipped over the x-axis. So 1 above becomes 1 below the x-axis. This point at 4, 2, my y-coordinate is 2. Technically, multiplied by a negative 1 makes it negative 2. So that point that's 2 above is now 2 below, and there's the flip over the x-axis. So outside changes your y's from positive y's to negative y's. That flips over the x-axis. If my negative is on the inside of the function, now that's going to make it flip over the y-axis. Remember, this is where your x's have to change. I'm going to go from positive x's to negative x's. That's flipping over the y-axis. So every point flips over the y. So I'm at the origin, I'm on the y-axis, I'm not going to flip. But this point is at 1, 1, so my x-coordinate of 1, which is 1 away from the y-axis, gets multiplied by or in this case, divided by negative 1, which is the same as multiplied by negative 1. We flip it over the y-axis 1 squared. For 1 to the right, we're now 1 to the left. At 4, 2, here my x is a 4, divided by negative 1. I'm 4 to the right of the y-axis. I'm going to flip and become 4 squares to the left of the y-axis, and that's reflected or flipped over the y-axis. So what we're going to do with all these transformations is we're going to put them together in a function, and we need to know what order things have to be done in. So when we put these all together, all those changes, there's the times a to the front, there's the times b to the x, there was the plus d on the outside, here's the minus c on the inside. The order in which we do these transformations is what we've all done before. Orders of operations is our master rule. We do this for everything. So we start inside the parentheses, inside the function. Well, there's multiplication or adding and subtraction. So multiplication is done first. So this value being multiplied by x is the first thing that's going to have the transformations done. So that's going to be either flipping over the y-axis or horizontal stretch or shrink. Next is we take care of this constant. That's the second, minus c on the inside. Then we go to the outside multiplication is a, that's the third. And adding at the end is always last fourth. So looking at the b, inside the function, this affects your x-coordinates. Number 1, we saw if b was negative, it flips over the y-axis. And then for number 2, our horizontal shrink and stretch, if we take the b, take its absolute value, which means the negative is now gone, and if that is greater than 1, it's a horizontal shrink by the factor of that new b value. And if your absolute value of b is somewhere between 0 and 1, some fraction, that's a horizontal stretch. Okay? All right. Now, I should go to here second, but I'm going to go to A next for the following reason. This is on the outside and it affects the y-coordinate. So I want you to look at the 2 rules for 1 and 2 in blue and compare them to 1 and 2 in red for the b. If you notice, all the x's and y's are switched. Every terminology is its opposite. Okay? So if a is negative, it flips over the x-axis instead of the y-axis. If the absolute value of a is greater than 1, it's a vertical stretch, completely opposite to horizontal shrink. If the absolute value of a is between 0 and 1, it's a vertical shrink, completely opposite of horizontal stretch. So this is what I do. I've noticed in so many college algebra books, there's more different values being multiplied to the outside of the function where a is at compared to where b is. Predominantly, you might see a negative here being multiplied, and every once in a while, you might get a 2 or a 3. Not too often. More than likely, you see more numbers multiplied to the outside. So what I tell my students is, hey, look, if you're going to memorize this, just memorize the A rule, because your B rule is completely opposite of what A is. But just remember, you got to do the inside first. Okay? Now, on the inside, bx minus c, here's a great trick. Remember I said earlier, it's in parentheses, set the whole thing equal to 0, and solve it for x. This will tell you the appropriate sign, the direction you want to go, and how far. It takes into account whatever you multiply to b. Okay? So if on the inside here I had a negative x minus 4, I'm not going to the right 4. I add over the 4 and then divide over the negative, which makes it a negative 4. So now I really go left 4. So you got to watch those minus signs. You just can't look at the c. You got to look at the whole binomial, set it equal to 0, solve for x. It will tell you the direction based on its sign, and it will tell you how far to go, the value. Again, d we said is outside the function, affects its y-coordinate. If it's a positive, a plus d, it goes up. If it's a minus d, we go down. Now, am I going to give you a function with all these transformations in it and ask you to graph it by hand? No, I would expect you to go to your calculator and graph it if you want to see the picture. What I want you to be able to do is look at this function right here and describe the transformation. Don't graph it, just describe it, okay? And make sure you put them in the right order. So here, if we practice this one, remember where to check. We go inside the function. That's the square root symbol. There's a negative right here. That's the first thing I do. Okay, negative flips over the y-axis. That's the first description. Next, we look at the bx minus c. We take negative x plus 5. The whole thing on the inside, set it equal to 0. Solve it for x. Okay, just add over the x. X equals positive 5. Positive means we go to the right, and the 5 tells us how far. So we're going 5 units to the right. Then we go to the outside. Here, we're technically multiplying by 2 numbers, a negative 1 and the 2. So there's really 2 transformations here. So the negative is the 3. That's the flip over the x-axis. And then you look at just the 2. Okay, 2 is greater than 1. That's a vertical stretch by 2. And last but not least is 3 over here, the plus 3. That's up 3 units. Now, if I put this on the test, this question here is worth 6 points. 1, 2, 3, 4, 5 points, and then 1 extra point if you put these all in the right order. So if you accidentally said, oh, 3 units up here after the flip or before the flip, you get the credit for the transformation, but you don't get the point for having it in the right order. Agreed? Now, when I do ask you to graph transformations, I'm not going to ask you to graph all 5 things. Again, that's crazy. And I won't give you a function like this to graph. I'm not stupid. You'll just plug it into your calculator and plot the points. Okay? The way I would give you a test question is I'm going to give you a graph of points where I'm going to connect them together. Short and sweet. No more than 4 points. And then I'll call this graph my f of x. And then I'll say, okay, I want you to graph f of x minus 2 plus 3. So on the inside, x minus 2, set it equal to 0. That's x equals 2. All those points are going to go 2 to the right. And then the plus 3 is on the outside. That will be done second. They're all going to go up 3. So you can move all 4 points 2 to the right first. And then take all 4 points and move them up 3. Or if you want, you can do both of these changes to each point. Okay, 2 to the right, up 3. 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 Plot your points and you're good to go. All right. Second one, using the same graph, negative x minus 5. F of negative x. So that's inside. That's going to change my x's from positive to negative. That's flipping over the y-axis. All right, so we're going to flip this. So this point's 3 to the left. It's going to go 3 to the right. 1 to the left, 1 to the right. 1 to the right, 1 to the left. 3 to the right, 3 to the left. So there's my flip. And then the minus 5 on the outside tells me, okay, those new 4 points are all going down 5 squares. Same graph if we have y equals negative 3 times f of x. All right, negative 3. That's going to be technically 2 transformations. Okay, we're going to flip it over the x-axis and then do our vertical stretch. Or, because it's all on the outside, a quicker way is just to find all the y-coordinates and multiply it by negative 3. So at this point being at negative 3, 2, take the 2, multiply it by negative 3 is negative 6. Okay, negative 3, negative 6. Just move that point down here. This point's at negative 1, 1. Multiply that 1 by negative 3 makes it negative 1, negative 3. This point's at 1, negative 1. Take the negative 1, multiply by negative 3 makes it 1, positive 3. So I'm doing the flip and the stretch at the same time. This point's at 3, negative 1, so that will be 3, comma, negative 1 times negative 3, positive 3. Connect them together, and there's your graph. Graphing y equals f of 1/2 x. Remember, multiplying half on the inside is a horizontal stretch. You can think of it that way, or, okay, it affects the x-coordinates in its opposite of the operator. So multiplying by 1/2, we could say divide by half or multiply by its reciprocal, so times 2. Take all those x-coordinates of the original graph and multiply them by 2. So negative 3 times 2 is now negative 6, 2. Negative 1 times 2 is now negative 2, 1. We don't change the y's, we just change the x's. 1 times 2 is going to be 2 comma negative 1. 3 times 2 is 6. This will be at 6, negative 1. Connect up those blue dots, and there's your graph. All right. So y equals f of negative 2x. We're going to let you practice these. Okay, this was, we multiplied by 1/2 earlier, so now instead of multiplying all your x's by a negative 2, you're going to say, I want to divide them all by negative 2. So hit the pause button, and then plot your points on your own. Well, welcome back. So hopefully you took all your x coordinates, like we said, and divided them by a negative 2. So negative 3 divided by negative 2 is 3/2 or 1.52. Negative 1 divided by negative 2 is going to be a positive 1/2 comma 1. 1 divided by negative 2 is negative 1/2 comma negative 1. 3 comma negative 1, so 3 divided by negative 2 is negative 3/2 or negative 1.5 comma negative 1. Connect those points up, and there's your graph. Okay, I'll give you a minute to try this one. So again, hit the pause button, make your graph. Hey, welcome back. So here, inside, we're going to want to move everything to the left first. Remember, opposite effect, x plus 3 equals 0, x equals negative 3, left 3 units. And then the 2, once you move these points to the left 3, and you find those new points, you'll take all those y coordinates and multiply them by 2. So let's move our points. So we're going to go 3 to the left. So now this is going to be at negative 6, 2. Negative 1 minus 3 is negative 4. 1 minus 3 is at the negative 2. And 3 minus 3 is at 0, negative 1. Then you want to take and multiply 2 to your y coordinate. So the 2 times 2 is 4, so that moves it to here. 1 times 2 is 2, so that's negative 4, 2. Negative 1 times 2 is negative 2, so that's going to get stretched down to negative 2 comma negative 2. Negative 1 times 2 is going to make that y coordinate a negative 2, but we don't change the x coordinate, 0, negative 2. We connect them together, and there's our graph. All right, good job.